Well, thanks everyone for joining us today for the Lunch and Learn of the week. Today we're talking about continuous integration and automation for embedded builds specifically. And the title of the talk is, What If I Told You There Are Tools Better Than Jenkins? We see a lot of folks using Jenkins. It's a great tool. It's just not the end all be all for some things, and I want to just kind of talk about where it makes a lot of sense, and then some things you might not know about that are valuable in Jenkins, and then some things that are valuable in some other tools that might be things to look at as well. So hopefully you get a lot out of this. While we're doing the talk, I'd say feel free to toss Q&A in whenever, and you should be able to click down at the bottom. I believe there's a Q&A button that you can hit there and just be able to Q&A that way. If you have any, and just do that as we go. I'll probably stop and answer them unless I'm in the middle of something, so feel free to do that. Otherwise, let's get rolling. So real quick, my name's Joe. I got a family of 5 that I'm super proud of, so I like to put their picture on all my presentations. I used to be at John Deere, did some services work also, and now leading Dojo 5, which is focused on firmware excellence. We're passionate about building great cultures and high-performing teams. And Dojo 5 really, focused on modernizing firmware and the whole life cycle there. Dojo being immersive learning, which you are taking part in right now, and our outreach efforts to get more people thinking about how to modernize firmware. And then the 5 foundation and family. So we consider you guys family, and we take that approach with everyone that we work with. We're based in St. Paul. So I've used this slide before in some of my other talks, but embedded development is tragically behind, in my opinion. The mobile and the web guys have all kinds of cool stuff: mature unit testing tools, amazing debuggers, one-click DevOps, real-time monitoring, quick, reliable deployment, and great CI tools. And I think, let's see, did I just close? I closed some window of mine, but oh well, I think that's okay. I got too animated with my arm there. The mobile and web guys are they just have everything. They have great CI tools. In this case, I'm talking about the CI tools. I'm just like, hey, I'm not saying I'm jealous, but I'm kind of jealous of what they got. How close can we get with embedded? And so I'm excited to that's one thing that we're really passionate about is trying to make those CI experience for embedded folks better. Assumptions a little bit on this. I'm not going to go through like a ton of details. If you want me to slow down, there aren't a ton of people today, so I could add some background if you feel like I'm going over your head or you want me to elaborate on a certain thing. But I assume you kind of know the goals of CI. Why do we do continuous integration? And we're trying to integrate code multiple times per day. And there's lots of tools and techniques to enable this, not only on the automation side, but even like process type of tools within your team, how you work, how you structure your code, and how you work together. Those are all pieces of this that enable CI. And so I'll just kind of make that assumption. So plan today, we're just going to talk a little bit about Jenkins, what it is. They're the elephant in the room. They're the big leader market wise, probably about 70% market share overall on CI/CD that I've seen. And a lot of embedded folks use it too. It's open source, it's fairly mature. It has a large set of plugins, and so people kind of go there first. Then we're going to talk about needs and capabilities of a CI/CD system, what alternatives exist for them, a rubric that kind of helps you score things, and then Q&A. So yeah, as I mentioned a couple times already, they got about 70% market share, 1,000 plus plugins, 10 years old at least. They used to be called Hudson before it was called Jenkins. So if you knew it before, from the before times, or if you run across blogs, you'll still find blogs online that talk about Hudson. Microchips, IDE still has a Hudson integration, which would work just fine with Jenkins, but so there's a lot of like kind of history there. I'm pretty sure, I guess I didn't research this beforehand, but I'm pretty sure that they got caught up in the Sun Microsystems buyout to Oracle, and or I think Oracle technically owned some part of Jenkins at some point, or the brand name or something. And anyway, it was Hudson before, and so then I think Oracle tried desperately for a couple of minutes to make Hudson a thing and turn it into a pay service. And yeah, luckily they didn't make that go anywhere, because Oracle kind of kills things that they work on. So they but Jenkins came out of it. It was basically the open source community taking kind of, I think, the last open source version of Hudson and just moving it forward. So yeah, it's been amazing, I think, for furthering the adoption of CI and automation in not just firmware, but especially in the mobile and web space. And then yeah, what's not to like about Jenkins? It's got so much going for it. And I would say, just real quickly on this topic, and we'll get in, we won't touch all of this, so I want to do it on this slide now, but the thousands of plugins is both a plus and a minus, honestly. All of the plugins are largely community owned, open source, which is great until they're like 5 years old and nobody's updated them, and they mostly work, but sometimes they don't, and so that's where I think Jenkins sometimes struggles, is in that plugins is a blessing and a curse. It makes it look really, really appetizing to bring it in, but at the same time, then it doesn't always do what you're hoping it would do sometimes, and it becomes you're debugging somebody else's code, really. 10 years old is a blessing and a curse there too. They do have a new UI called Blue Ocean, and I've got a Jenkins talk that's asked me if you want the recording, where we went through and set up Jenkins and kind of walked through the whole thing. But they're old school. I mean, their standard UI is looking a little old and dreary. And so if you want something that's, looks modern, that has modern features in it, largely you won't get that out of the base UI. They kind of got on the Docker train late. And so if you're familiar with Docker, that's a technology that helps you utilize clean and build environments, really, and repeatable, reusable build environments, which becomes, a lot of people will set up Jenkins initially and just use the tools that are installed on the Jenkins machine and just use the hard drive that Jenkins is running on it. And that can get you a little ways, but if it always bites you at some point, and usually right before a release, and usually when you've got a big deadline, and that's when the repeatable builds are really important. And there are other enablers for repeatable builds too in the Docker images, having to do with scaling out to the rest of your team, having the same build environment, not just on the development machine, but on everybody's machine. And so a lot of things there. But it is open source, so that's cool. It uses some wonky stuff. There's a lot of Groovy in there. So if you've never programmed Groovy, you might get into some integrations that you're not as familiar with. And otherwise, it's mostly based on Java. So if you're not a Java fan either, or you don't know much of it, like open source is great, but unless you're going to dive into a bunch of Java code, it's not like you're going to be making some extra plugins or fixing bugs or something. So anyway, it's a love-hate for me, because I love how much market share they've got and how they push CI/CD forward, but I just feel like they really aren't really innovating anymore, and that's where I'm excited, and where Dojo 5 is trying to innovate as well. So what do we need from a CI/CD? And I got a CD/CD, but I meant CI/CD there. Well, we need it to be repeatable, meaning that we can get our builds out over and over again the same way. This is really important for firmware. I feel like you've got a build from 2 years ago, or a device in the field from 2 years ago, and you get a crash report from it. Maybe you've got the console log, maybe you've got a memory dump, maybe you're lucky enough to have a memory dump or something from it. But in any event, you're going to need to figure out, like, it would be really great if you could Git helps us get back to the source code for that, but a lot of times you might need an ELF file, to run the debugger against this crash dump, or you might need map file, symbol file, or something. We can talk about being able to save those as artifacts off your CI system. But if you have a repeatable build, you don't even have to worry. You don't need to archive it. You know that you can get those back anytime you want. And it solves so many debugging problems, especially with devices on the field, especially when it's been months and months and months since you've looked at that code. Reliable. If you put together a CI system that is flaky, it becomes more of a nuisance than it is a help. You end up spending a lot of your time debugging the CI system rather than debugging your code. And so here you've got this computer that's supposed to be automating all of these jobs for you and helping you out, and instead it's causing more problems. So it needs to be reliable, it needs to be rapid, just meaning like fast. If your build takes a couple hours, it's a lot less valuable than if it takes a couple minutes. And some of the tools can handle that, some of the tools can't. And debuggable. If some of the tools are better at showing output than others, and helping developers understand why they failed or not. And I just kind of said, basically, you want it to be boring. You want it to work in the background, do your bidding, and largely fade into the background and just keep it going. So, so the framework that I kind of put together for an initial firmware pipeline a lot of times, and this gets adjusted for a lot of folks based on what their exact needs are. This is a typical pipeline. You've got a trigger, you've got some compile step, trigger and checkout really happens together there, and then you compile it, then you run unit tests, then you run the static analysis, or SAST as it's kind of being called now, a static application security testing, and then dynamic analysis, which is basically a dynamic form of that, simulation and hill testing, and then a deploy of some kind. And deploy might mean deploy to your QA team. It might mean deploy to over-the-air updates, for a whole fleet of devices. There's a big spectrum there as far when it comes to embedded, what deploy means. But the web and mobile guys, a lot of times deploy means deploy to deploy to the app store, deploy to the cloud that's running on staging. It can mean deploy to production, maybe 1% of production to start with, then 10%, then 100%. So there's a lot of, I get really excited talking about all this because there's a lot of analogous technologies I think could really bring a lot of value to a lot of folks working in the device and the embedded and firmware space that just has not been all put together under one roof yet. So we're going to dig into each of these kind of sections of the pipeline, just talk a little bit about what types of needs you have and what types of things we can kind of evaluate different solutions on. So from the trigger standpoint, roughly 4 types of triggers. There's probably one more, but this is roughly what you get. Scheduled, but these are a bit old school. This would be like, we build every night at midnight, or we build every night at 10 p.m. The reason I say they're a bit old school is because if you're really following CI/CD, it should just be building every time that you check in. And a lot of times the reason people do scheduled builds is because their full pipeline takes too long to run during the day, and they don't want to tie up all their resources during the day. So they schedule it to run at night. And it's not terrible, it's better than nothing, but I think bleeding edge, state of the art is to use technology, use the best tools, and then you can run a lot of these things in parallel. You can speed them up, you can run things in simulation, and now you can get to that kind of ultimate panacea of, like, we run a huge suite of tests and it runs very quickly, and only the tests that need to run will run. And so we really kind of optimized your pipeline. A push hook, which is the most common way. Basically, when I push code, it kicks off a build. Manual could be clicking on a website. A lot of times there's a QA step involved that's manual at some companies, where they want QA, human in the loop somewhere to say, like, yep, I signed off on this, and then click a button, and then more automation takes over again. Or API, which is basically like hitting a REST endpoint, or hitting something from a script, or maybe you're connecting two different, like Bitbucket to GitHub or something. Like you're connecting multiple tools together, and you can trigger things that way as well. On the compile step, most of these at this point support shell makefile type of builds, CLI builds or command line interface builds. I threw in there IDEs and environments like IAR, Kyle, etc. All the fun stuff that we get to deal with as embedded engineers. Yeah, those tools are 10, 20 years old. They weren't built initially with any accommodations for CLI, and those have been hacked in, and now they both have ways to build from CLI, but the documentation is a little wonky. IAR just very recently announced that they have now a Linux version of their build, like as of May, and I don't know anyone that's actually taken them up on that yet. So it's I'm excited for it. I want it. That's the way they need to move, and I hope it pushes Kyle in the same direction. But that's largely running those types of things from CLI has been a little tricky in the past, and continues to be tricky, I'd say. Docker image support, not all of these tools support Docker images. And then, as I mentioned, the benefits of Docker are, these clean, sterile environments. That's how you get to repeatable builds, both locally and on the build machine. Batch files, Windows support. Not all tools have Windows support. So if you're stuck on a Windows-only tool like IAR, has been mostly, or Kyle, then you kind of need that. Flash and RAM metrics are kind of one of several like embedded specific type of features that have a lot of value for embedded folks, but aren't typically included in most CI/CD platforms. But I mean, I'm sure if any of you folks on the phone have had that situation where you're getting close to a big production release, and there's just one more feature to add in, and you pull in a little more of printf or something, pushes you over the edge, and all of a sudden, boom, you're out of Flash. And now you've got what should have been, like a 20-minute, adder right before the production release turns into an 8-hour, optimization session of what can we pull out of Flash to make this thing fit. It kind of catches you by surprise, and that's the types of things that are not being added to CI/CD systems, because the embedded community, frankly, is kind of a niche, and we want to support that niche. And whereas like the big guys like GitHub and Bitbucket, GitLab, there's so much work from mobile and mobile and web that I don't think they're really focused on us. From a unit test perspective, again, making sure that you have shell makefile access to run them, XML report formatting, and really JUnit format. That is the common language for most of these, and you'll find that most unit test runners have an option to format the output in this XML report formatting format, and then all of the like display because what you want to do is not just generate an XML report or any kind of report. Frankly, I never want XML most of the time, but what I want to do is I want to be able to see a list of all of the unit tests that ran. I want you to highlight the ones that failed. I want to be able to dig in if I want to, but I want to be presented with the exception cases. Some of these tools allow you to navigate the test results easily. Others, basically it's like have fun downloading the XML file, or you end up digging through the console logs. Associate build changes easily with results. So that's again, like, what change do we make on this particular unit test that caused us to fail the build? Static analysis. So in our world, it's things like PC-Lint, Coverity, Clockwork, others. Reviewing code for CVEs, password scanning, certificate updates, expiration scans. These are all things that have caught a lot of embedded folks, and have caught a number of web folks too, but they're getting better at it, and I think we need to catch up. And more embedded devices are on the internet, and these are the types of things that happen. People accidentally check in their Amazon IoT core credentials. Oops. And there are scanners that are running on GitHub all the time. And if you accidentally have a public, it happened to another company that I work with, you accidentally make fork a repo and make it public, oops, if that anywhere in that repo there's a Amazon credential, and within hours it's almost certainly compromised. And so, knowing that, and when you're in a PR, or knowing that when you're about to fork, rather than finding out when you get the AWS bill for $20,000 because they turned it into a Bitcoin mining operation, is not the way you want to find that out. Certificate updates, expiration scans, that's just like, that we're all starting to realize that we need encryption, we need certificate encryption with roots of trust, and that means you've got expiration dates, and how are you going to handle those? Who's going to remember that in 3-4 years? Review reporting. I don't know of any standard output format for a lot of these tools. But again, what I don't want to do is dig through a giant blob of console output. What I'd rather do is see it presented to me with exceptions, and then largely just show me green check boxes if everything's working right? And I want to be able to dig in if I want to prove to myself it's working, but otherwise bring me the exceptions. Prioritizing results and promoting those to issues. And an issue tracker is another nice type of feature here, as well as fast runtimes and license capable. And I added license capable because IAR and Kyle have similar issues, but a lot of these old school firmware tools are Windows only. They use FlexLM. I mean, and so you've got this interesting situation where, like, I really want to run all of these tools on the cloud and a runner that I can provision, and somebody else worries about keeping it online. And we just, we pay, minute by minute for that, like on AWS or wherever, your cloud of choice. And that sometimes presents issues when these things have network licenses that you need to be allocating and considering. And what if you've only got one and it provisions it for half an hour, and somebody at their desktop, it needs to work on the unit tests, and you're using a tool like VectorCast for automated unit testing. So what do you do with those? It's an interesting problem when you want to just automate what you're doing. And then the dynamic side of things. This is stuff like, okay, now we're going to get the thing up and running, and we're going to run something on this as more of a black box. So things that I feel is like really bleeding edge for firmware. I don't know many people doing this. Things like fuzzing and pen testing. Things like the ETSI 103645 or NIST 8259, which has not yet been adopted, but very soon will be. And these will become best practices for embedded internet connected embedded devices, and just security best practices for these devices. Generating and browsing results from these tests, and then being able to prioritize those results and promote to issues again. They're kind of working through that workflow that I think we're all familiar with, and we know what needs to happen, but has not really been brought together into one roof. And then simulation and Hill, again, especially simulation, I feel like is pretty bleeding edge. There's a couple companies that have done it well in the past. Pebble's one that sticks out. They had full simulation unit testing on their Pebble Watch, from very early on, but they are definitely the exception. Most places, they're not doing hardware in the loop testing. They're not doing simulation. This step is called throw it over the wall to the QA guys, and then they do manual testing on it. I think we can get beyond that, and it doesn't have to cost a lot of money. I think the simulation tools are getting to the point where we've got a lot of examples from the web and mobile space of how to do it, and we've done it enough times in embedded that what we typically see is when companies try to invent this in-house, and that's really the hardest part of this whole thing, is they try to invent this in-house. They sometimes throw a junior engineer on it, and then it becomes a 6 to 9 month science project, and they don't always nail it, or they get something that's basically in-house and now it needs to be maintained in-house too. So but there are tools available today that can do accurate CPU platform board simulation on a lot of like ARM style cores. There are other cores as well that they can support. Flashing target hardware, reading, writing the IO from the Hill standpoint, running target scripts on the target. So this is like some people might have called unit testing hardware, basically testing on the device. My definition of unit testing is testing on your host PC and testing like the logical functionality of your code. Those run like thousands in a second, you know, and here's where we'd actually be testing on the actual hardware, and largely the logic and the features are figured out at this point, and they've been tested to, you know, kind of proven correct. And this is more like, okay, what weird, you know, interaction with the hardware, or what peripheral or clock on the clock tree do we forget to turn on? All of those fun stuff that you have when you actually get onto the hardware, and things really need to work. That's the type of stuff you're sniffing out here at the hardware in the loop test. UI testing is another big one. You need to test this largely. I've seen embedded groups solving this through QA groups and doing it manually. There are a number of tools. Squish with Qt just happens to be one that gets used a lot, but there's others. I think, but a lot of people, it's like homegrown. They almost have to spin up like a person or even several people to kind of own that and maintain that. And I feel like we can be doing a lot better there. Reviewing results is kind of the same thing again. Like I need to be able to see what happened. Like if a UI test fails and it just says fail, like I don't really know how it failed. I'm gonna spend a lot of time debugging it. So reducing that cycle from like, when do I enter a bug, to when do I discover that it's a bug, to when do I discover the root cause, to then when do I fix it? Like compressing all of those stages is really the goal with all of this. Then Hill device provisioning allocations, you know, presents a really interesting, unique challenge, because then you've got Hill devices, and we end up, you know, if you go all in on Hill, then you've got a number of devices that are usually pretty valuable to the company, but you need to schedule them almost, because, you know, whenever a build kicks off, you want to use them for, you know, what might be 5 minutes of a Hill run. But then later, you know, at the same time, somebody at their desk might say like, hey, I'd really like to have, you know, this piece of hardware. You can go grab it from the hardware lab. Well, now it's not available for, you know, the continuous integration pipeline. So what do you do in that case? Or maybe you have a way for that person to access it remotely from their desktop. But again, you've got to be able to schedule that, and you got to decide what happens to your build pipeline when that happens. So provisioning allocations is another big interesting piece of that. And then deploy capabilities. So, you know, in a lot of cases, deploy just means, you know, copy a hex file to QA guys, or artifact storage is what it's typically called in the CI/CD world. When you store anything like hex files, or your XML output from your unit tests, or the report that was generated by PC-lint or whatever, you call those artifacts. That might just be all you do, is you just save them. And a number of most of the CI/CD tools can save them like that. But you might want to do something more. Maybe you are in a situation where you've got like beta testers or alpha testers, or in-house, you know, fleet of devices that you want to push to OTA. You know, maybe for your hardware in the loop testing, you want to push that out as it's now been deployed, and becomes kind of like our canary builds, as some people call them, right? You might want to monitor and manage that rollout. Maybe you are ready to roll it out to 1% of the users. This is really patterned after what the web guys are doing. You know, when you're moving very fast, as I believe firmware is firmly on the same path that web and mobile are on. They're just, it's a slower curve, but I think we're headed to the same place, where there's a lot of value in, you know, I don't know, taking an example, you know, Amazon and Google, and, you know, they're both vying for you to be the hub in your house, you know. I've got both, and they get updates, you know, somewhat frequently. I don't even know they're happening, because they happen overnight, or when I unplug it and then plug it back in, a lot of times it'll take an update. But there is, you can bet that there's a managed system that's deliberately focusing on making sure that rollout happens appropriately, making sure that when they roll out the updates, that they don't roll out an update that can't take further updates, because then you got a bunch of bricks in the field, and that's no good. Then you got and you've got a giant recall on your hands, and a mild catastrophe. And so that's there's a lot of ways to shoot yourself in the foot with the deployment. And so the state of the art is really rolling deployments out, where you start with 1% of the users, and then you watch a certain number of health metrics. Are users still interacting with it at roughly the same rate? When you've got enough users to start to be able to see those numbers in aggregate, and you can start to make inferences like, like we probably broke something on the settings portion of the app, because the number of people going into settings cut in half, and then you investigate and figure out what's going on, or maybe you automatically roll it back, and then do the diagnosis offline. But that's what state of the art web and mobile guys are doing these days. I got a question from somebody. Are there any Hill simulation tools and platforms relevant for embedded testing? For sure. I can talk a little bit about that now. I think there's a couple of them. Qimu, or is one simulation platform that a lot of people have heard of. It's a little older, and it's a little bit of a beast, I'll say. But that's what Pebble used very successfully to do their hardware in the loop testing for their smartwatch platform that they had for a number of years. And even they engaged developers and were able to have developers testing their own code, because they had kind of a little app store almost, really, before Apple and Google were even there. And so the tool can be wrangled into doing simulation for you. Google has a open hardware testing framework, or OpenHTF. That is their kind of contribution to hardware in the loop testing. There are a number of other kind of command response. Largely, honestly, what I see is people, again, inventing the wheel over again, creating a command line interface on their device, and then often a Python script that runs on a desktop machine. And raise your hand if you've heard this before or you've seen this before. But that's what typically gets built over and over again. It's just the same thing. I would say, so yeah. Those are two that I know of, and then Renode is another really interesting simulation tool that's come about. It's not particularly CI friendly-ish, but there are ways to wrangle it into CI, and actually it's a pretty nice platform. It is missing some peripherals for some platforms, so you can't kind of necessarily expect that it's going to have your chip. What it's got is at its core, it's got pretty good ARM instruction set simulator. And so it can run the ARM instructions, but then where it needs to be fleshed out a lot is in the peripherals. So it doesn't necessarily have all the peripherals. We do a lot of Nordic work with the NRF52 series, NRF53 and 91, and those peripherals aren't built out. And so we've been looking at helping to build those out. There are a number of other simulations that are built out, and so those have served us well in certain cases. So. But yeah, those are the tools that I'm aware of. And if you have any other ones, feel free to share those too. Yeah, so we kind of, that's kind of, gives you an idea of all the different pieces of these build pipelines and some embedded specific kinds of things, and me just kind of pointing out where sometimes you hit some limits. I've got a market analysis linked down there. I'll send out a survey after the presentation. So if you respond to the survey, then I'll send you the slides and you can have that. But the main takeaway on this slide is just there's a lot of options, right? GitHub, I'm sure you've heard of. We talked about Jenkins, GitLab, EmbedOps. EmbedOps is our tool. Just full disclosure: Bitbucket, Bamboo, Travis CI, TeamCity, Drone.io, Circle CI, Cloud Build, Azure DevOps. There's several others, many others probably that I've missed. And I guess all I'd say is that almost all of them are really kind of primarily focused on web or mobile, or even for Jenkins, it was really building desktop apps to start with. So it wasn't, these guys have all come kind of from that world, and the embedded engineers, bless their hearts, they have found ways to hack it together to make it work in firmware. And yeah, anyway, there's a number of alternatives to with each of these, and many of those guys can sit on both sides of these equations, but you got to decide whether you're on-prem, self-hosted, or whether you're going to be cloud-hosted. There are pros and cons to both. Your IT group, if you're at a larger company, might have some opinions on what you can do here. But hey, but if you're a small company or you work for yourself, like, hey, congrats to you. You get to pick. Self-maintained versus software as a service, cloud runners versus local runners, and runners being like the execution environment when it actually performs a build. In some cases, like in old Jenkins, that was just the same machine, but there was a lot of value in like separating those two things, like the web dashboard from the actual execution environment, and so we were able to kind of separate those out. The Docker environment versus just the host environment. Host being you just build with the tools on your Windows machine, and maybe you're running Docker or Jenkins on the same machine that you actually do your development on. You can do that too. Or maybe you've got a Docker environment that mirrors the environment that then gets used on your kind of more professionally run cloud-hosted environment. Or cloud provider versus an independent. Basically meaning to say, like, there are AWS, Google, and Azure, all three have a version of builds that, of course, are just part of the mouse trap that's trying to, or the fish trap that's trying to trap you in their ecosystems. But hey, if you're already in the ecosystem and you like it and it's working, then they can be good options versus grabbing one of the many other independent options that are out there. So I put together a little rubric here, and this is, kind of for reference, but I'm going to just walk through it a little bit, comparing some of these items for some of these tools. So like you can see, like from a triggering standpoint, everybody can do all the triggers. Those are pretty stock out of the box things. Compiling for the shell script, everybody can do that. Bitbucket has a pretty big hole right now that they can't do any builds on Windows. Everybody else can kind of. They've had beta floating around for a while for Windows. I imagine they'll probably mainstream that at some point shortly. But for the moment, that's a little hole, especially for embedded folks that we've needed to work around a couple of times. Because if you got folks on IR Kyle, that support really isn't there. So what do you do? How do you get build pipelines in place? Docker supported everywhere at this point. Compiling batch files supported everywhere you have Windows, pretty much. Some of these embedded specific things, I'm highlighting that just, Embed Ops has that out of the box. Most of these other guys are just not focused on embedded, unfortunately. And then unit testing, I mean, like we're starting to get towards bleeding edge. Most people, like state of the art, or not state of the art, but just kind of general population has really, gotten through the compile step, and then they just breathe a big, deep breath and say like, okay, let's just call that good, right? And then it's really like more the leading edge folks that are like, okay, well, we definitely got to get the unit tests in place. First they got to be writing them, and then they got to be actually executing them. And then, like even like GitLab kind of fails here on easy navigation. When you have the unit test report, depending on what format it's in, navigating that can be basically you download it, and then you have to save it to your hard drive, and then you have to unzip it in your download file, and then you have to open up the HTML file that's inside, and then you can finally, read it. So it can be a little wonky that way. And then as far as static analysis or dynamic analysis type of tools, Simulation Hill and then Deploy, I mean, a number of people, because of a decent amount of focus on security, password scanning, CVE scanning, most places have that. Again, Bitbucket, I feel, is a little behind here. But things very embedded focused, like embedded linters, fuzzing, pen testing for embedded, it's, unless you're working with an embedded first tool, you're going to be building this out yourself. In most cases, what we see is people just don't build it, and then they just kind of roll the dice a little bit. Simulation, again, nobody's got it out of the box or Hill out of the box, except for the embedded focused tools. So, which I believe we're the only ones. Deploying artifacts, everybody's got all that. And then, OTA support, again, is really an embedded specific feature. But it's exciting, though. I think there are so many things that have been brought from the web and mobile world that we're getting, the embedded folks are largely getting for free. All of these things are just kind of coming for free, and it's been really nice to see that come through. So I think my takeaways really at this point are just, hey, there's lots of options. Most are focused on web and mobile, and there's a lot of work putting these lines together on your own. And there's also a lot of maintenance then, because I don't think that it's done once you, like the first day that you get to work, as we all know, once you're maintaining products, or once you put a product in play, and you make it part of your critical infrastructure for delivering your products, it's you're going to be maintaining it too. And yeah, I'm plugging in BedOps a bit. If you'd like a demo, definitely let me know, and we can get that set up. Otherwise, that's all I had for today. Kind of chatting about all the other options that are out there besides Jenkins, and some of the pros and cons with that. And I'm happy to take any additional questions that you guys have. Yes. So we got a question about on DAST. Can I elaborate a little bit on DAST? So there's a lot of, I feel like this is a pretty new area for the embedded space. You can see, like, I feel like the NIST and the ETSI is a European standards organization. Those best practices are really largely they're playing catch up, to be honest. There's things in there like, why do we still have medical devices that get shipped with default passwords? It's just and okay, like, forgive the medical guys, or like even once we get the medical guys fixed up, there's a number of other devices. I mean, you go to Shodan, if you don't know what that is, you can Google it, and you can find webcams that are sitting on the internet wide open, and those that's because they got shipped in an insecure way, and people plugged them into the internet, and and didn't think twice about it, and they don't realize that anyone can drop on their webcam and see whatever they see. So we just things like those embedded security practices will be things where we can test that certain aspects of a system are met in an automated fashion. And then the pen testing is we have experience with putting together a lot of like different kind of like common attacks for internet connected devices. So once you kind of build a little bit of a toolbox of where sometimes there's some holes, you build up kind of this recipe of things that you can come across. Fuzzing is where you're let's say you've got an embedded device that has some kind of API, and little known to you, and maybe the static analysis didn't catch it, but there's no input validation on one of the inputs. Maybe you can send it a command to do something, and you can overflow a buffer. That's what fuzzing does. Fuzzing tools do is they try to send this somewhat randomized data to all of the input kind of surfaces that you can find on your system. And in some cases, they can find an issue. To this day, we're still finding issues with the Bluetooth spec, with kind of some stuff in Ethernet. It's Wi-Fi continues to have various attacks on it. So You know, I mean, we're on like version 3 or 4 of passwords, you know, password encryption negotiation for Wi-Fi. So there's just like a lot of things that, you know, I don't, none of these tools claim to find everything, but they'll keep you from making the known mistakes. And that's really the most dangerous ones, is the ones that like, because like a friend of mine has said a number of times to me, it's like, if you want to break into a system, all you got to do in these days is just go look at a device that was built 5 years ago, and probably it's not getting updates. And then you just go find you just go find, you know, what are some vulnerabilities for that device, and you can start trying them out. You know, in a lot of cases they're built into you know, kits that help you compromise devices. That's been the bane of a lot of Linux class devices, but you know, as we get more and more bare metal devices and RTOS devices on there too, I mean, those are just as vulnerable. There have been vulnerabilities in lightweight IP. There's been vulnerabilities in a lot of other, you know, common libraries that you're probably familiar with. And making sure that you don't have any known vulnerabilities is one of the big pieces here, and just treating this black box. So let's see, I've got a couple other questions. Do we support Hill with code coverage reporting? So the answer is yes, but we do some of that custom. So it just depends on what you're coming in with as a particular testing framework. Like I mentioned, that OpenHTF is one that we know, and we can get coverage out of that. You know, it gets tricky with coverage on the device, which I think is what you're saying, and that's where you need to be running usually an instrumented version. There's two ways to do it. Either you run an instrumented version of your code that runs on the device that can report back coverage or store coverage somewhere, or you do something fancy with instruction trace stuff through a JTAG or some other device where it can watch your coverage that way. There are tools that we integrate that do that as well, where it's not necessarily us building it from scratch, but it's us integrating those tools together so that it's quick and easy, and you get the result that you want. Let's see, any decent DAST tools out there? Yeah, I should put together a list of I mean, I would say that like there's not a tool that you're going to say that's like it's the pen test tool or something. It's more like, what are your attack surfaces, and there are certain tools that you go after it with. So I think, you know, the pen testing that we typically do is you know, evaluating the surface. You know, there's a planning stage that happens, and it's just like when you plan unit tests or hardware in the loop tests. You know, you figure out, what are my requirements, and it's really, what are my attack surfaces, and then what do we, you know, what types of vulnerabilities, what types of attacks do we think are the highest risk and the highest impact, you know, highest severity if they exist, and then you kind of you know, make your attempts to try to get into the system in those ways. There are a number of things too that are very hardware specific, like a lot of JTAG devices will allow you to you know, dump the memory or modify execution paths and stuff. And so in a lot of cases, you want to disable JTAG on production devices. And in fact, I believe 8259 recommends that, among many other things. And so, like, that's, you know, that's some things that you want to consider, I guess, when you're thinking through that. But yeah, I'll follow up on that as far as what you know, maybe just a list of like, here's some different interfaces, here's what we typically use for pen testing and fuzzing, because those are evolving, I'd say, daily. Let's see, another question. Does your tool support exercising lab-based test equipment, power supplies, external stimulus? Okay, so what we see a couple different things. So, you know, a lot of that is typically depends on the lab equipment you've got. You know, you have Agilent equipment or Keysight equipment, or you've got, you know, National Instruments stuff is typically automated in that fashion. So I would say, you know, we don't have we don't have that stuff like built in out of the box where it would be like, you know, like we auto discover your National Instrument stuff somehow, because all of that is custom already. And so, but we absolutely could pull that National Instruments stuff into our tool, and then, you know, be running automation on those devices. That's typically how the Hill stuff is done. You know, like typically what we start with for Hill is just powering on the device, power control, and then being able to talk to the console. And then it gets very custom after that, depending on what IO a user has. Blue Clover is a good company to look at too. They're trying to kind of commoditize the hardware necessary. So there's another good option if you're not familiar with them. They're kind of a new player in the market that's trying to really target, like, why do we need $10,000 worth of National Instruments equipment to test if my, you know, small device is working correctly with different voltages. You know, Blue Clover is really trying to make that cheaper and better, and just a good user experience. So check them out if you haven't heard of them. But yeah, we can integrate with the Blue Clover stuff, or we can integrate with the National Instruments stuff. That's stuff that we'd work together, or that's when we work with folks, we work together with them to figure out what they want, and then, you know, either where embed ops really is helping us, I guess, is to say, like, all of these initiatives have been, you know, build it in-house and keep it proprietary in the past. And what we're able to do is, like, if you're using a National Instruments module or using a Blue Clover device or whatever that we've done before, then we can just, you know, we can basically build it much more cheaply and much more quickly, you know, than it would take to kind of build the whole thing up in-house, because we can just kind of reuse that information. Even if we haven't done before, if we see the need for that to, you know, or if we see that as something that others will be able to reuse and need, then, you know, we know that we can sell it at a discount and then advertise it as a additional service. And that's something that we can, you know, we just want to get this flywheel spinning of, like, let's get to really good CI systems, so that we can just move things forward in the industry. All right, cool. Well, that was awesome, guys. Thanks for all the questions. Really appreciate it. And as always, on the last slide, if you guys have any questions, feel free. You know, more events are posted on the dojo5.com events link. If you like this, please let me know. I'll send out that survey. Please let me know that way too. And then yeah, dojo5.com, Joe Schneider. Feel free to email me directly. I'm always happy to talk. So thanks so much. Really appreciate it. Talk to you guys later. Bye.